Assalamualaikum. We are from Group T. We would like to present about our oil and gas simulation project. First of all, I would like to introduce our group members. From the picture, from the left is Muhammad Zakri Iezaac, and the second one is Muhammad Raziq. The third one is Muhammad Syahir, and the last one is Hanis Hanani. Okay, we proceed with the description of the reservoir. The size of the reservoir is 150 meter by 150 meter and by 6 meter with 3 layers of equal thickness. And the number of the cell for X and Y direction are both 50 and 50. So the other information about our reservoir is the depth of the reservoir is at 2000 meter. The initial pressure is at 270 bar. The porosity is at 0.3. The permeability in X direction is at 1172, 1143, and 1162. For permeability in Y direction is same as the permeability in X direction. And for the permeability in Z direction, the permeability are at 1050, 1800, and 500. So the other information are the rock compressibility of the reservoir is at 4.67 times to 10 to the power of -5. The oil density is at 860 kg per meter cube. The gas density is at 0.853 kg per meter cube. The oil water contact is at 2460 meter. So there are also other data given regarding the reservoir, which are the data of water and oil relative mobility and capillary pressure, the data of PVT properties of water and oil, the data of PVT properties of oil, and all the data given are shown in the table. So at the table 1 is the water and oil relative mobility and capillary pressure data. At the table 2 is the PVT properties of water, and at the table 3 are the PVT properties of oil.
Now, let's continue with the production planning coding. So this is the project coding that has been assigned. First one is the schedule, which specifies the operation to be simulated. RPTRST is indicate the restart file. Basic equals to 2 indicates an additional input will be provided from this coding. The first one is a well spec. Well spec is an introduction to the well, which is in this case, we have a production and also injection well. The coding start from inserting the well name, which is in this case, we have a production well and also injection well. The group of well, the I and J. I and J indicates the location of well head or hill. Is 2500 indicates the bottom hole pressure, and the well phase is indicates the fluid inside the well, which is for production well we have oil, and injection well we have water. Continue with the COMDAT. COMDAT is specify the position and properties of well. The coding start also with the well name. The I and J that indicates the location of grid block. 1 and 3 indicates the K1 and K2, that is an upper connecting block inside of data. The K2 is a lower connecting block inside of data. Open or shut indicates a flight of connection. which is in this case we are having an open flag of connection. This one is a default values. 0.1 indicates a transmissibility factor for the connection. wcon product. wcon prod is specify the completion data of the well. It starts with the well name. Again, the flag of connection is either open or shut, but in this case we are open. The control mode, which is for the production well, we're using a LRAT, which is a liquid rate. This one is default value. 100 is indicate the rate of this fluid. This also a default value, and 135 indicate the bottom hole pressure. The same coding are used for the production well and also the injection well. Now go to the tuning. Tuning is for the alteration of this project coding. And the time step indicates a specified intervals between reporting times, which is in this project we have 50 steps in 30 days. The end is a termination of this coding. Every coding will end with a slash.
Thank you, Hanis Hanani. My name is Zakri and I will proceed with the data output from program section. In the question, several specific command has been requested. First, create block pressure and water saturation into restart file at each report step of the simulation. As a result, rptrst basic equal to command has been written in the schedule section. Next, initial permeability, porosity and depth data with keyword init in grid section mentioned. Thus, init command has been written at the last part of the in the grid section. In addition, initial grid block pressure and water saturation into a restart file with keyword rptrst in solution section mentioned. The same specific command as the first instruction, which is rptrst basic equal to 2, has been written at the end of the solution section. Okay, now let's proceed to the next slide, which is the summary section. Summary section specifies a number of variables that are to be written into summary file after each time step of the simulation. Without summary section, Eclipse does not create any summary files. So as you can see at the left side, which is FOPR, FPR, FLPR, FWIR, FWIT and FWPR is the command that has been requested as mentioned in the question. A total of 12 summary command has been written in the command of Eclipse. So FOPT, FWCT, WBHP. Not to forget, a slash must be followed after a command that start with letter W. FVPR, FPIR and FOE. I think that's all from the data output from program section. Now I will pass to Raziq Roslan to explain about the result and graph. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and greetings. My name is Muhammad Raziq bin Roslan from Group 3. I will present about the result gained from all the computation and coding using Eclipse software. Okay, my first discussion will be on the field liquid production rate, field water cut, and field oil production rate against time. As you can see in the screen, the red line indicates the field liquid production rate, and as you can see, the numbers of field liquid production rate will be at 100 cubic meter per day. So the next one will be the blue line, which represent the field water cut
and it shows that the line are increasing as the time goes by. However, the 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 increased value becomes significantly reduced as the time goes by. The last one is the green line, which is the field oil production rate. As you can see, it suffer declination as time goes by. The next graph will be the field liquid production rate, water injection rate, reservoir volume production rate, reservoir volume injection rate, and field reservoir pressure against time. As you can see in the screen, there are multiple lines that indicate all the parameters mentioned before. So the surface production rate, which is FLPR, is set at 100 meter cube per day. The reservoir production rate can be calculated using the equation, which are FLPR multiplied by oil formation minus by FLPR multiplied by FWCT multiplied by the difference between oil formation and water formation. Okay, the FLPR when the FWCT is 0 and when the the oil formation is 1.178 will be 117.8 meter cube. The equation used will the equation mentioned before are used in order to get this value. The next one will be the calculation involve the FVPR when the FVCT is 1, which is mainly focused on 100% water, and BW means the formation water is 1.02. Okay, after applying all the values mentioned before, the answer will be 102 meter cube. Okay, the next parameters needed to be calculated is reservoir injection rate, which is FVIR, which is can be calculated using FWIR, which is 150 meter cube per day, multiplied by what formation of water. So after using all the inputs needed in the calculation, the FIR will be 153 meter cube. Okay, the trend will be the drop in reservoir pressure can be proved as the higher initial reservoir production rate is higher when compared to reservoir injection rate. The third graph will be the well bottom hole pressure injection and well bottom hole pressure production and field pressure rate against time. Okay, from the trend of shows by the graph, the highest pressure recorded is 680 bar, which is from the well bottom hole pressure for the injection part against time. We can conclude that all the line, which is the parameters mentioned before, reach plateau or constant state after it reach a certain threshold, which is time. Okay, the final graph will be the well bottom hole pressure injection and well bottom hole pressure production against time. As you can see in the picture, we can see that both production and injection for bottom hole pressure start at 0 initially, which is represented by the red and green line. And also you can see the trend that both well bottom hole pressure for injection and production increase significantly at constant rate as the time goes by. I also want to deliver some additional information about the trend. There are several modifications made in order to ensure that the shown graph in the picture can follow the same trend as you can see from the graph. That is all for me. Thank you. Finally, I would like to use this chance to offer, as a representative from my group, to offer gratitude and appreciation to those who spend their time in order to watch this video. I think that's it from us. Thank you for watching.